This is something that you want to consider when you are researching your apartment costs also. Okay, so utilities include electricity, gas, oil, and water. Heating oil is not really used down here in the south. We don't have to consider that here, but in the northern climates, because it doesn't freeze, they use heating oil through their pipes, and the oil gets heated, and then it runs through the house and heats the air. So these are things that you need to take into consideration. Some apartments include some of these and some don't. So you might rent an apartment where water and sewer and trash are included. Oh yeah, they didn't put that on here. There's also sewer and trash. Why is my pen giving me a hard time again today? Most of them it's included in the rent, but not all of them. My last rental before I bought my place, I had to pay for that myself. So that's something that you want to look into when you're deciding what apartments you want to rent, is do they include those water, sewer, and trash in the rent? Because if not, you're going to have to pay for it yourself, which means it's a different budgeting, right? So this is just something to take into consideration. So I told you that electricity is about 3 or 4 cents per kilowatt hour. But what does that mean exactly, right? Like, how many of us know how much kilowatt hours you're using when you charge your phone or when you run your TV? I have no idea. But they're registered on a meter, and then they come out and they read the meter. Okay, electricity is measured in watts. A watt is a unit of electricity, and a watt hour is how many watts are used in an hour. Okay, but when you're being charged watts, you use so many watts of electricity, they go ahead and make it kilowatt hours. So it's how many kilowatts are used in an hour, and that's what you're being charged for, is the kilowatt hours. And a kilowatt is 1,000 watts. Right, kilo is 1,000. So for every 1,000 watts you use in an hour, it's 1 kilowatt hour, and that's how you're charged. And if you look at this here, a 60-watt light bulb uses 60 watts in an hour. Okay, so that kind of gives you an idea of how much electricity it's using. Okay, any questions on these topics? Things like water and natural gas are sold by the cubic foot. So, you know, cubic foot is volume.
Does everybody have a gas bill even if their stove and their water heater are on?
No. You only have a gas bill if you have a gas water heater and gas stove, and a gas house heater. It depends. They fluctuate. Sometimes electricity is more expensive than gas. Sometimes gas is more expensive than electricity, and it just depends on what the yields are, really. If you use solar, you have the cost of the setup and the maintenance, because solar energy, your house is solar, it's only generating electricity while the sun's out. So you have to buy big battery banks to store the electricity, because once the sun goes down, you wouldn't have electricity anymore. So you have to buy these big batteries, and they only last a certain length of time. So you have to budget all that in, like how long the batteries last, and how many you need, and how often you have to replace them. So it still costs money. It's just a different cost. So cubic foot is the volume, and so it's CCF is 100 cubic feet. That's right here. What are you doing? Not you, the computer. And remember, cubic foot is foot cubed, and that's literally a cube. That's a 1 foot by 1 foot by 1 foot cube. So if you were to take water and make it a square block, 1 cubic foot of water, sorry, 1 cubic foot of water would be a square block of water that was 1 foot by 1 foot by 1 foot. And that's how they measure it. So even though we think of water in terms of gallons, it's measured in cubic feet. The meter doesn't get reset every single time, every single month. Like they don't reset it to 0 when they read it. What happens is they take the previous reading. So if they read it on April 1st and it said 10, then they come back on May 1st and it says 15, then you used 5 that month. So they subtract the previous reading from the current reading. That's how they do that. So if we look at Tom's water bill, the previous reading was 3,128 CCS, which is 100 cubic feet. And the present is 3141. So we're going to take 3141 and we're going to subtract 3128 and subtract those. And I'm going to cheat and use my calculator because I feel like it. And that's 13 CCFs, which if you wanted to know exactly how many cubic feet of water that would be, it would be 1,300 cubic feet. And if you want to know how many gallons that was, you'd multiply it by 7.48. So it would be 9,724 gallons, roughly.
That's a lot of water.
So each of these represents 1 digit. So this is the first digit, second digit, third digit, fourth digit, and fifth digit. Okay? Now, if we haven't hit the 1 yet, this is 0. You always go to the number down, not the number up from where you are. Does that make sense? So this one is a 0. Here I'm between 9 and 0, but we're reading this way, not this way, because it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm a 9. On this one, 1, 2, 3, 4, 5, 6, I'm a 5.
Oh, yeah, I see what you're talking about.
Here I'm 1 through 5 again. This way, I'm between 5 and 6, I'm a 5. And here I'm 1, 2, 3, 4, 5 that way. I'm between 1 and 2, so I'm a 1. So this one would read as 9,551. Yeah, you always go to the lowest one because what happens is as this one rotates around, this one will rotate very quickly. And then as this one rotates around, it starts at 0. As soon as it hits 0 again, this one goes from 5 to 6. But because they're actual dials, as this one rotates around from 0 to 0, this one starts to move from 5 to 6. It's not instantaneous. And then as this one moves from 1 or 0 around back to 0, this one is moving from 5 to 6. So when this hits 0 again, this one will hit 6. And as this one moves from 0 back to 0, this one's going from 9 to 0. So when this one hits 0, this one will hit 2. Do you see what I mean? So as you move from right to left, the dials get slower. This one on this end moves very slow. This one down here moves very fast.
So always 5 down.
No.
There could be 4. Here, hold on 1 second. Let me
Typically be pretty satisfying to watch.
meter here. All right, so we're going from 1 around this way, so this one's 3. 1 around this way, that one's 3. 1 around this way, that was 5. And 1 around this way, so that one's 9.
So what happens if you have one of these things and it goes all the way up to like 9, the first one's 9?
Once this hits 9, 9, 9, 9, and they're all 9, then this one will go to 0, 0, 0, 0, and it resets back to zeros.
I thought the person said that when it's in between, you go to a lower number.
You do. Starting in the direction that you're going.
Unless it's at 9, 0,
So between 9 and 0, you're at 9 because 0 is actually the next rotation around. Does that make sense? So in that case, that 0 is a 10.
You could just explain what the form is on the left, just so it's a form.
Yeah, you just follow the numbers in number order 1, 2, 3, 4, 5, and then whatever arrow, whatever you're next to.
Do you want these back?
Sure, you can put them in there. Okay. An electric mixer requires 125 watts. This is per hour. Okay. How much would it cost to run the mixer for a total of 90 minutes at a cost of 10 cents per kilowatt hour? So we've got 90 minutes, and we want to convert that to hours. How many hours is 90 minutes? Yeah. 1.5 hours. And 125 watts, and I want to convert that to kilowatts. And so to do that, I'm going to divide it by 1,000. Okay, because 1 kilowatt is 1,000 watts. So 1,000 divided by 1,000 would be 1. Okay. So, and for this, I divided by 60. Okay, so if I divide this by 1,000, I'm going to end up with 0.125 kilowatt. Okay, so I've got 1.5 hours times 0.125 kilowatts. I need to take that hour off, sorry. So I'm going to multiply those together. And I am going to use 0.1875 kilowatt hours. Okay, does that make sense so far? I figured out my hours, I figured out my kilowatts. Times those together, you get kilowatt hours. And it's at 10 cents per kilowatt hour. So I have to multiply by 10 cents. And this is going to cost me a whopping 2 cents to run.
That's ridiculous. Don't worry.
Very, according to the seasons, makes sense, right? In the winter, you're running the heater. In the summer, you're running the air conditioner. In the spring and fall, you're switching back and forth between the two because the weather's schizophrenic, right? Especially in Florida. Like, what was it? Like 90, and then it was 40, and now it's like 80 over a 3-day period. So,
Did it snow like 2 weeks ago in Wisconsin?
who knows? So, there's something called balance billing. Okay, now here's how that works. They take your average electricity for the year. So, let's say you normally spend, just as an example, you normally spend like, okay, we'll just make it easy. We'll say you normally spend $1,200 per year. And then the electricity company would divide that by 12, and then they would charge you $100 a month. Okay, and maybe one month you're actually using $80 of electricity, but another month you're actually using $120. And so it balances. It's called balance billing. And most electric companies will offer you this because it makes it easier to budget. Because in Florida, summer electric bills tend to be higher than winter electric bills. In Maine, winter electric bills tend to be higher than summer electric bills, right? But you can budget it, they'll balance it out so you pay the same amount every month, so you're not hit with, like, in June you have like a $70 electric bill, and then in December you have a $450 electric bill or something.
Like the money, like if you spend too much, you pay them, and if not, then you have to get it back.
No, they carry it over to the next year, and then they'll adjust accordingly. So, like, if the balanced billing after the end of the year, you ended up not paying quite enough, they raise the monthly payments a little bit on the next year to absorb it. And if you paid more than, like, too much, then they lower them on the next year to figure it out. Like, they'll adjust it to make it work out well. So, this family spent $3,336 per year for electricity on last year. So if we take that 3,336 and we're going to divide it by 12. And that's exactly what the electric company does. So their balanced electric bill would be $278 per month. Now, let's say you are moving to a new place and you want to do balanced. What they do is they look at the average usage in that area. Like if you don't have a history with them of a year, then they look at the average usage in the houses right around you and base it off that, and then adjust it as
So
necessary.
that's only if you want to do that.
Only if you want to do balance billing. If you don't do balance billing, then you pay for the exact amount you use.
When me and my mom,
Okay, so energy savings often pay for themselves. So if you, for example, buy more energy efficient appliances, sometimes what you're going to save in electricity will pay for the appliance over a course of a couple years, right? So their old water heater was $455 per year to run. Okay, so the new one they purchased, they paid $1,240 for it, but it's going to save them 31% annually. So we want to figure out how many years would that pay for itself. That's how you decide if it's worth it or not. So we're going to take that 455 and we're going to multiply it by the 31% it's going to save them every year. So they're going to save $141 in electricity every year. Yeah, and then we take the cost of the water heater, we divide it by the savings. I'm just going to do 141, and it's going to take, it's 8.79, so we'll say about 9 years. Now, if this water heater has like a 10-year guarantee, then you know it's going to last for 10 or 15 years probably. It would be worth it. If this water heater has a 5-year guarantee, but it's going to take 9 years to pay off in the savings, it's not really worth it because it might break down again, and so you might go with a less expensive water heater option that might not save you as much per year, but won't cost you as much up front. So that's the way you kind of make those decisions. Like my